in this question, we're going to try to find alpha so that this integral of this function, which is 1 over t times ln of t to the power alpha between e and plus infinity, we want to show that it does exist. Okay, the first thing that we need to do is we want to check the function for any discontinuities. So here we have 0, but we are not integrating around 0, and also we have 1 because the natural log of 1 is 0, but that's not a problem. The only issue is we have this infinity. Therefore, we can define this one as the limit as x goes to infinity of this integral e to x 1 over t ln of t to alpha dt. Okay, so this integral exists all the time for x bigger than e, because we know it's the definite integral that we know. Moreover, we can compute this one. We can compute the primitive of this one, even if it looks here different. We can use some change variable like y is ln of t, and we can quickly get this one. Okay, but let's see that this is just, let me see the limit as x goes to infinity. So this is just ln of t to the power minus alpha plus 1 over minus alpha plus 1. Okay, between e and x. So when I do the evaluation, I'm gonna get the limit as x goes to infinity. So I have 1 over 1 minus alpha, and here I'm gonna have ln of x between to the power 1 minus alpha minus just 1. Okay, now if I try to take the limit, this power will play. Let me write it nicely. Limit as x goes to infinity of 1 over 1 minus alpha ln of x to the power 1 minus alpha minus 1. So this one, when I take the limit, this is a constant. When I take the limit as x goes to infinity, so if this one, if 1 minus alpha is bigger than a certain value that they have to determine, okay, I'm gonna get this one bigger than 0. Okay, if this one bigger than 0, so this one will go to infinity. But if the 1 minus alpha, if 1 minus alpha is less than 0, that means alpha is bigger than 1. Okay, this one will go down and will go to 0, and this one will be finite. Okay, so that's it. My condition is that if alpha is bigger than 1, then this integral is convergent. And this is it. This is it. You don't need any other thing except to notice that when you take the limit, check the values of alpha. If 1 minus alpha is bigger than 0, then this one will go to infinity. If this one is less than 0, okay, we get a limit that will go to 0, and therefore we have a finite integral. Okay, there is one more case when alpha is 1. So when alpha is 1, we have, yes, when alpha is 1, we can just, okay, let me see. When alpha is 1, we can just, let me see, e 1 over l t ln of t, okay? So the limit as x goes to infinity, so the primitive here is just ln of t between e and x, and this is infinity. Okay, so this is the primitive here in this case when alpha is 1. So alpha has to be stricter than 1 to get this one convergent, because if you plug alpha is 1, you're gonna get this one that we know. So, and when you take the limit here, you're gonna get infinity. Therefore, this integral is convergent in the case of alpha is 1. Therefore, this one exists when alpha is bigger than 1. Okay, Thank you very much.